Let's see if this works. The camera is resting on the dollhouse. Okay, so background on tangent. Unit circle first. When you think about the unit circle, right, and you talk about the tangent of any angle on the unit circle, how do we calculate tangent? Tangent gets calculated as the y-coordinate over the x-coordinate, right? The problem with that is because this is a ratio, as I work my way around the unit circle, there are certain values down here that I don't want to see, right? I don't want that to be 0. So along the unit circle, there are two spots where this x-coordinate is 0. Where is that? Right here at pi over 2, and down here at 3 pi over 2, right? So, long story short, because the coordinates here are 0, 1, and 0, negative 1, when I put these in a ratio together, that's no good. Negative 1 over 0. No bueno. So, how does that fit into the graph of a tangent function? What that means is because I have undefined values of tangent, on a graph, when we graph things, if you think back to rational functions in chapter 2, it was a while ago, speaking of functions where we may have had like x minus 2 in the denominator. You remember what would happen if we had 2 for x, what we would do when we graphed it? That is correct. We would have vertical asymptotes. So, we're going to have asymptotes in a tangent graph. Now, I said before that this is a 3 pi over 2, right? And that's correct. If this is 0 and this is pi over 2, 3 pi over 2 would be over here. So here's pi. Now the thing with tangent, the way that we frame a tangent graph, is not by talking about starting at 0 and moving this way. Okay? We talk about tangent, and I can explain this better in person probably, starting at negative pi over 2, because we do have a graph over here. We do have negative values of pi that we graph for. We did the same thing for cosine and for sine. So we're doing the same thing here. So what we say for a tangent of theta is that our graph is going to go from negative pi over 2 to pi over 2. Okay? So we're going to start with that idea, the idea that there are asymptotes in a tangent graph when we go to graph it. So anytime, and because tangent is a periodic function, anytime we get to one of these quadrant angles, here and then back down to here, and then if we keep going and we keep rotating, we hit here again, we hit here again, we hit here again. Every time we hit that, we see another asymptote. So there's still going to be that repetitive behavior in our tangent graph, but it's going to be kind of cut off or bound. It'll have boundaries of asymptotes, if you will. Okay? Watch the next video to explain why a tangent graph looks the way that it does.